So it's going to use the following graph, or using the following graph, determine what the values of the zeros are, and the zeros are also known as the x-intercepts. Also describe over what intervals this function is increasing or decreasing. Alright. So, can someone give me, first of all, how many x-intercepts are there? 3. Alright. X-intercepts go right across the x-axis. There, there, and there. Alright. So, what is one of my x-intercepts? 4. Another one. 2 and 3. Okay. Now, what is the y value of all those coordinates? 0. So the point would be -0, -2, 0, 3, 0. Okay. Now, next piece, next part of the question asked is, over what intervals does this function increase or decrease? Alright, so increasing. What intervals did we have it increasing over? Ironically. -infinity to -3. What else? Union 1 to infinity. Something right around 1. Alright? Good. Again, when you talk about a function increasing and decreasing, you're describing that interval using the x value. Okay? So, decreasing. Who? -3 to 1. Anywhere else? Good. Alright. Questions about that? Consider about negative infinity to -3 and 1 to infinity. Okay. Questions about that? So, starting now, since we have a whole unit that I want to refresh your heads, we're going to have warm-ups. You can come in, sit down, write it down, do it. Good. Alright? No, like, you can do your put notes underneath it. Alright? So typically it will tie deal with something from the previous day, but also tie something in from the first unit. Alright? So, here we go. Yeah. Oh. Yes. Alright. So here's some things you need to remember. We didn't specifically. This is like stuff that you should remember from not my previous classes. Alright. So the first thing you need to remember is a polynomial is a continuous function. We call it polynomial because poly means many, known, like NON means that refers to the terms. It is a many-termed function, meaning it has more than typically 3. Alright? So, what you need to know is this. A polynomial function of degree n can have at most n real zeros. Okay? So, if you have a function that is a 4th degree function, it could have 4 zeros. Could not have 5. Alright? So, and the other thing to remember is zeros are going to graph the polynomial function across the x-axis. Okay. Zeros are also going to be referred to as solutions. So I say find the solution to this equation. You're finding the zeros. Right? You're finding where it comes from the x-axis. Now, I have 2 examples of graphs drawn here. Okay? I have these drawn to make a point. go down to this again. So first of all, we have two equations, two functions up here that are almost the exact same function. We have y equals x to the fourth minus 3x squared plus 4. And we have y equals x to the fourth minus 3x squared minus 3. Alright? Now, I want to point out here is, first of all, what is the degree of the function y equals x to the fourth minus 3x squared plus 4? Fourth degree polynomial. That tells us that it can have no more than 4 real zeros. Okay? It can have 4, it can't have more than 4. We graph this. It has 1 0 there, 1 0 here, 1 0 here, 1 0 here. Now, what do we mean by real? Real means that, you know, it could be a decimal, it could be a fraction, it could be a square root of 2 type of thing, an irrational number. It just can't be square root of a negative number, which ends up giving us non-real numbers. So zeros can be any number we want, any number. There's no restriction on it. It all depends on what the function is. But what is important to know is that this function right here has no more than 4 zeros, 4 real zeros. Now, that being said, I want to show you another example. Okay? This is a fourth degree function. Y equals x to the fourth minus 3x squared minus 3. This function has how many zeros? 2. Plus the x-axis twice. So, my reason for showing you this is two functions that are pretty similar, yet there's a big difference. This one has 2 zeros, that one has 4 zeros. Alright? So, where do we go from here? Now, here's the thing. It's easy to look at a graph and figure out what the zeros are. You're not always going to have a graph. Right? So there's several different types of real zeros, 2 different types of real zeros. Rational, irrational. Okay? Rational zeros are going to be things like -3, 2/3, fractions. Things that you've written as fractions. Irrational zeros, is plus or minus the square root of 5. You can square root of 5 is like 2.7. 2 point, and it's a bunch of decimals that don't repeat, they go on forever. Okay. So, I want you to be aware of that there will be 2 different types of zeros. You're not always going to have a nice zero, alright? For instance, if you do real life problems with this type of math, you're typically not going to have a nice zero. This is not how real life works out. Alright? So, another thing I do want you to notice. One way we can find the zeros is by factoring. Alright, and solving for x. That's a common way to find the zeros. Another way is to use quadratic formula. You know another quadratic formula? Pressure. No such thing as that on quadratic formula. Actually, memorize. Need to be. Alright, so that's quadratic formula. That's another way to solve quadratic functions and find the zeros. Okay? Now, if you need that, I'll probably remind you. So, and you write this down. It is a lot. This is on a page in the book right here, but it's called the rational zero theorem. Okay? It describes how the leading coefficient and constant term of a polynomial function with integer coefficients can be used to determine a list of all possible rational zeros. Okay? And so the theorem says, if f is a polynomial function with degree n greater than or equal to 1 with integer coefficients, and a sub 0 is not equal to 0, that means it has a constant. Then every rational zero of f has the form p divided by q, where p and q have no common factors other than plus or minus 1. P is an integer factor of the constant term a sub 0, and q is an integer factor of the leading coefficient a sub n. Okay. Sounds probably confusing and slightly weird, and I will explain it using it. Alright. You guys don't say it like this one. So there's some important things to remember here. Okay, number one, this can only be used, the rational zero theorem can only be used as long as the coefficients are integers. So the numbers in front of x, they can't be decimals. They can't be fractions. They have to be integers. Alright? Alright. The other important thing that you need to remember, when you look at the polynomial, there has to be a constant. Alright? You can't have a place where there's no constant. If there's no constant, you can't use this. Okay? So there's two sort of instances here. Your leading coefficient could be equal to 1, or your leading coefficient might not be equal to 1. We're going to look at the cases where the leading coefficient is equal to 1. Alright? So what we want to do, right? We have this function right here. We want to list the possible rational zeros of this function. Now, raise your hand if you're not sure what we're trying to find out. Raise your hand if you don't know what that means. Fine. Alright. So basically what we're doing is this. We have this function. Right? Do we know what this graph looks like? No, we can take a guess. Like, we know it's going to look something like a cubic function, so it might look something like that. We don't necessarily know what it looks like. We don't know where it crosses the x-axis or anything like that. But what we do know, because of this theorem, is this function x cubed plus 2x plus 1. Are all the coefficients integers? Yes. There's no decimals or fractions. Is there a constant? Yes. Okay. That means I can use the rational zero theorem. What the rational zero theorem is going to help me do is find out where might this function cross the graph. Where might this function cross the x-axis? All right. So how do we do this? Well, we're going to do two things. All right. First of all, the leading coefficient is 1. It is 1x cubed. Remember what? Can someone tell me what the leading coefficient is? But how do we know it's 1? What is the leading coefficient? Huh? Nope. The leading, none of the coefficients can be fractions or decimals. How do where do we find the leading coefficient? From the variable that has the highest degree. So the highest degree is 3. So therefore, my leading coefficient is the coefficient in front of this x cubed term, which is 1. Right. So here's what we're going to do. We have to find two things. All right. What the theorem tells us is that all these zeros, any zero that is a rational zero for this function, all right, it's going to be of the form p divided by q. All right. Now, p those are factors of constant. Q is factors of leading coefficient. Alright? Which should be easy to see why if the leading coefficient is 1, it's kind of easy, it's kind of nice. Because the only factor of 1 is plus or minus 1. Alright? So we want to actually find out what are the rational zeros. What could these zeros be? Right? What zeros could this function have? All right, so to do that, we need to know, the factors of the constant. We need to know the factors of the leading coefficient. So what is our constant term here? All right, so our constant equals 1. All right, so we need to find the factors of 1. So what are the factors of 1 are what? 1 and negative 1. So what I'm going to do is I'm going to put plus or minus 1. Alright. Now, we also need to figure out the factors of our leading coefficient. The factors of our leading coefficient are what? Or what is our leading coefficient? 1. So what are the factors of our leading coefficient? Minus 1. Alright, so this is a little bit easy. Alright. Now, so now what we can say here, alright, again, this is going to be where we get P, this is where we're going to get Q. Alright? The factors that this, or the rational zeros that this function could potentially have, I'm just going to divide each value of P by each value of Q. Alright? So I'm going to have, so I can have positive 1 divided by positive 1. Alright, so P divided by Q would equal positive 1 divided by 1. Alright. My P can also be negative 1. So I can have negative 1 divided by 1. And so divided by 1 over here. I could also have, positive 1 divided by negative 1. 1 divided by negative 1. I could also have negative 1 divided by negative 1. Now, I got some repeaters up there. Alright? What is 1 divided by 1? So 1 divided by 1 is 1. What is negative 1 divided by 1? Negative 1. What is 1 divided by negative 1? Negative 1. What is negative 1 divided by negative 1? Positive. Alright? So what is the only the possibilities are positive 1 or negative 1. So instead of writing, I don't need to write out all 4 of these. Alright? What I can actually do is say, alright, this is going to be plus or minus 1 divided by plus or minus 1. No matter what, if I divide positive by positive, negative by negative, if I divide 1 by 1, I'm going to get, if I divide plus or minus 1 by plus or minus 1, I'm going to get plus or minus 1. Alright? We just showed that. So, this is kind of a lot of work for nothing. So what we can really do is go ahead and say, all right, P divided by Q is plus or minus 1 divided by plus or minus 1, which is going to be plus or minus 1. So what does this mean? All right. It's a, if we graph this, the only places where this function could be equal to 0 and have to be like a rational number, like a fraction, or like a nice number, is positive 1 and negative 1. Okay? And if we actually did this, we graph this. Alright, what we can do is we can graph this and see, alright, is this true? Are there really any places where are there really any other places where this could have a 0? Alright? So we have y equals x to the third plus 2x plus 1. Huh? So, what it says here is this. Alright? It says that my possible zeros, that are my possible rational zeros, the only ones that it can be are +1 or negative. Well, obviously we can see it's not negative. It's not positive. So if we find that zero right there should be something that's like a crazy number. So if we did second trace, we're going to find the 0, 2, down here, here. This comes out 0 is 0.4533977. It's going to go on forever. That's not a rational number. All right. So by graphing that, we're able to see, okay, neither one of these rational numbers are actually zeros. So the issue is going to be, how do we figure out if they are without graphing? So let's look at another problem down here. I want you guys to sort of walk me through it. All right. So, what do we want to do? We want to figure out what are the potential rational numbers, or rational zeros that we could have. We have to find P and Q. So, first of all, let's write this down. What is Lucas? P is what? P is constant. So it's not the constant. Factors is factors. Factors constant. Q is what? Factors of the coefficient. Factors of the coefficient. Okay, so real quick, our constant. What is our constant? -9. Good. -9. Not just 9. And it wouldn't matter. And what are the factors of our leading coefficient? Or my fault. What is our leading coefficient? 1. Right. So we need to find the factors of negative. We need to find the factors of our constant. So someone tell me. David, factors of 9. Say it again. The -9 and 1. Now, we can also have +9 and -1. So I'm just going to put, and I want you to get at it, plus or minus 1. Plus or minus 9. Alright? -3 and 3, so plus or minus 2. No matter what the number is, it's always a plus or minus. Because I can always, if I need a negative number, I can always do a negative positive. I need a 2 positive, if I do a positive, it's going to be positive, positive, and a negative, negative. So, what are the factors of positive 1? Plus or minus 1. Alright. So we have all the factors we need. Now what we need to do is find the potential zeros, potential rational zeros. Alright? So what we do, we divide each number that's here by each number that's over here. So it's going to be plus or minus 1 divided by plus or minus 1. So plus or minus 1 divided by plus or minus 1 negative squared. Plus or minus 1. Alright, what about plus or minus 9 divided by plus or minus 9? Or, plus or minus 9 divided by plus or minus 1. Plus or minus 9. And finally, plus or minus 3 divided by plus or minus 1. It's really easy. So here's the trick. Okay? If the leading coefficient is 1, your rational zero is going to be a factor of, your potential rational zero is going to be a factor of. You just keep dividing by the other. And it gets a little bit different when the leading coefficient is not. So, all this is the same. Alright? Okay? What is the same? It is saying if this graph, or if this function has any rational zeros, it has to be one of these. Any zeros that are not one of these means it's not rational. Make sense? So this function, the only rational zeros it could have are these. All other zeros it might have, not rational. So that means they're not nice, not fractions, they're not nice decimals, they're like crazy, like square root of 5 or something like that. Okay? So, I think the most logical step would hopefully be to yes. Alright? So now, we have one where the leading coefficient is not 1. Alright? The list starts to increase a little bit. Alright? Actually, let's call a timeout real quick. Alright? I want to go back to this problem. Down here. So, we have these potential zeros. Okay? We have these potential zeros. The issue is, we don't know which one of those, if any, are zeros. So, how can we figure out if any of them are zeros? What's one way to do it? Graph, we're not doing that. Alright? Diagram. Huh? You want to find it algebraically? Alright? There's a couple ways to do this. Alright? You can start by plugging positive 1 into x and see that it equals 0. If I plug 1 in there and it ends up equaling 0, good. Plug negative 1 in there and ends up equaling 0. Okay, I found a 0. We're not going to do that though. Alright? Why would we want to do that? Well, because as you'll see, eventually this could be a lot bigger. You can have 12 numbers over here, each with a plus or minus, which makes it 24 numbers. Do you feel like plugging 24 numbers in? No. Alright? Now, let's look at this. First of all, let me ask you this question. Is there any way possible that all 6 of those numbers, 1, negative 1, 9, negative 9, 3, and negative 8, is it possible that all 6 of those could be zeros? Why? Okay, so the whole could be 4. So I know that there's going to be 4 zeros. Now, I need to figure out if they're more rational. So how do we do this? How do we figure out if any of those are zeros? Well, here's the thing. Have you guys heard of synthetic division? If you hadn't had 3, you should have. If you haven't had that 3, you have. Alright? Anyone remember what synthetic division is? Alright. Synthetic division is sort of like a shorthand notation of how to divide a polynomial by a binomial. Alright? So, what does that mean? Well, if positive 1 is a 0, alright, it would be written as it could be written as a factor as x minus 1. Alright? So if positive 1 was a factor, or it wasn't 0, it could be written as a factor of x minus 1. Why? Because you can say x minus 1 equals 0, add 1 to both sides, you get x equals 1. Alright, that would have been our 0. So, to prove that that's a 0, what you would have to do is take x to the 4th plus 4x cubed minus 12x minus 9 and divide it by x minus 1. That involves you having to know how to do long division, which unfortunately is starting to come along apart. So there's a sort of a shortcut, a nicer notation that keeps your math more neat. It's called synthetic division. So what we're going to do, we're going to take this function and one of these zeros. So you guys pick 1 0. 9, okay. So we're going to take 9 and put it over here. Alright? Good. And you're going to want to write this down. We're going to put little boxes on it. We now want to check, or now we want to take our function. X to the fourth plus 4x cubed minus 12x minus 9. And we need to write down the coefficient for each term. So what is the coefficient of x to the fourth? 1. What is the coefficient of x to the third? 4. What is the coefficient of x squared? X squared. What is x squared again? No, you just say. That is. Yeah. There is no x, I can't put 1 so 0. So here's the thing. You have to have a placeholder for every term. If there is no term, you have to have a 0. Alright? So you can add x squared. What's the coefficient for the x term? Negative 12. And then what's our constant? 89. Alright. So first thing you do, so everyone with me so far? If you haven't seen this, I want to make sure. No comments. Just have it spaced out. You don't need comments. It's just you're writing down those coefficients. So you guys ready? Anyone recognize this yet? All right. So you're gonna bring the 1 down. You're gonna do 9 times 1. 9. All right. And then go over here. Add 4 plus 9 is 13. 9 times 13, okay. We'll keep going. Anyone knows? Someone do 9 times 13. 7, 2, 12, 11, 117. 117. All right, 0 plus 117, 117. At this time, writing all 4 block attendance entered. All 4 blocks attendance entered. That doesn't have to be done by any. 1,053. All right. Now, what someone do negative 12 plus 1,053 because I'm not thinking that hard. It's reserved for one of these. 1,041. All right, so we'll do 9 times 1,041. 9,000 what? All right. And then this negative 9 was negative 9 plus 9,369. 9,300 and what? 78. Sure about that? I think it's 9360. All right. All right. So you guys all have your calculators, right? I want you to do one thing. Okay, first of all, before you do anything, here's how you figure out if it's a 0. All right? 9 is not a 0. Why not? Because we get this number right here. This right here, this number in here. In order for 9 to have been a 0, that would have to have been 0. We need this is our remainder. All right? We need a remainder of 0. Alright? So in order for 9 to have been a actual rational 0, that should have given us 0. Now I want you guys to do something. I want you to type this into your calculator right here. But don't put X. I want you to plug 9 in. Alright? I want you guys to figure out what this number is. So you have 9 to the 4th plus 4 times 9 to the 3rd minus 12 times 9 plus, or minus 9. All right, I want you guys to actually do that on the calculator. There we go, look at my answer. Oh, yeah. Why didn't we? Because, okay, so here's what happens. You do all this, all right? The remainder tells you the y value when you plug this number into that function. So you can plug that in, and you should, if you plug 9 into that function, you should get 9,260. So you may be asking yourself, well, why can't we just plug 9 in? Well, we could. And we would find out that it's not a 0. But here's the thing. Now, once we get going in this, it's going to be a, let's see, there's going to be some shortcuts that we can use, all right, to sort of cut down on the amount of plugging in or synthetic vision we need to do. All right, so let's look at, let's just do one more. Let's look at, make sure I'm student, right? Alright, we're looking at -3. Alright, so what's the first thing I need to do? Write down all the coefficients. Alright, so we have 1, 4, -3, 0, -12, -9. Right? What's the first thing to do? Bring 1 down, keep 1. -3 times 1 is 4 plus -3 is +1. -3 times 1 is -3. 0 plus -3 is -3. -3 times -3 is 9. -12 plus 9 is -3. And -3 times -3 is +9. -9 plus 9 is 0. We found the next intercept. One of our x-intercepts is -3. If you plug -3 into that function, you'll get 0. Alright? So -3, so x equals -3 is one of our x-intercepts. Now, I want to show you something else. I want to find one more. Alright? So here's what you do. When you have synthetic condition, you're using things, and you find a 0. Okay? To start looking for your next 0, you do not use the coefficients in the original function. You're going to use the coefficients in this. Alright? And I want to explain why. Okay? So, calm down. Alright? So, -3 is a 0. X equals -3 is a 0. Alright? We can write that as a factor. So that would be x plus 3. Alright? So, because what we have done is synthetic division. We have divided our original function by that 0. Alright? We have divided our original function by this factor right here. Alright? So really what we have is, after we divide that, we have x plus 3 times, and then we take, you remember what we do with these numbers down here now? We use those because that's what we got when we divided our original function by the 0. So what we have is We started at x to the fourth, so this is going to be 1 x cubed plus 1 x squared minus 3x minus 3. Nope, the other good one is another.
What is about the 9? You wouldn't use that one for this.
This, I want to do that with 9 because 9 is not a 0. I need that x minus 9 not be factor. Yeah, in order to use it again, you need to use it. Alright, so to do it again now, I'm not going to use the original factor, I don't need to. Use those over there. Alright, so I'm going to take -1 just because I know it's going to work. So I have -1, and then I'll take these coefficients. So what coefficient do I use? 1, 1, -3. I bring the 1 down. -1 times 1 is -1. 1 plus -1 is 0. -1 times 0 is -1. -3 times, or -3 plus -1 is -4. Well, oh, yep, there's a mistake. -1 times 0 is 0. -3 plus 0 is -3. -1 times -3 is out of 3. -3 plus 3 is 0. So, x equals -1 is a 0. So now what we have, yes, is we have x plus 3 times -1 is a 0, so we can write that as a factor and be x plus 1 times, now we have x squared plus 0x, so I'm not going to write that, minus 3.
Well, you put the x cubed out of there.
Yeah. So each time you divide it and find a 0, the degree goes down by 1. Alright? And now, look at this. So my last factor, this factor right here is x squared minus 3. How many zeros do we say this one has? Or could have? That's 4 zeros. Right? So what we see is this could potentially be factored, or I could set x squared minus 3 equals 0. So that's x squared minus 3 equals 0. X squared equals 3. I take the square root of both sides, I get x equals plus or minus the square root of 3. Is the square root of 3 rational? Irrational. That might be why that did not show up. And I did p divided by q. Alright? So I know that this is going to be irrational because it wasn't part of it wasn't part of my theory that I did. Alright? Questions about that? I believe on your homework. Well, you guys probably have 2 minutes off of that. Alright, so let's look at this. I want to at least get through this one. It says, when the leading coefficient of a polynomial is not 1. Alright? So this can increase significantly. Alright, so, here's my question for you guys. What is the first thing that we're going to want to do? Determine the constant leading coefficient. Good. So determine it for me. Good. Constant is 8, leading coefficient is 3. Alright. So P is what? Factors of the constant. Good. So, what are the factors of the constant here? Huh? As Lonnie said 1 and 8, I'm going to say plus or minus 1, plus or minus 8. Alright. What else are factors of the Good. Now, what is Q? What are the factors of 3? That's 1, minus 3. Alright. Now what? Divide P and Q. Alright, what do I get? So plus or minus 1 divided by plus or minus 1 is plus or minus 1. What else? Minus 8, how do you get that? Plus or minus 1 divided by plus or minus 8? That'd be 1/8. Other way around, so 8 divided by 1. What else? 2 and 4. Alright, we're done, right? Good. You have to divide all those by 3. So we're going to have plus or minus 1/3. 1 divided by 3. 8 divided by 3 is going to be plus or minus 8/3. 2 divided by 3 is going to be plus or minus 2/3. 4 divided by 3 is going to be plus or minus 4/3. Oh boy, now we got like 8 up there. That means there's 16 numbers to test. You guys ready to do synthetic division? A lot? You guys don't have faith. No. You guys can start plugging in all 16 of those numbers to find out which ones are which. So I'm not going to do that. I'm going to be done before you. You do better. So, look at this. You guys choose a number that's not a fraction. You make that a -2, I'll like you better. 2. You want to be like better? Here's my first thing. Me personally, if I'm doing this, numbers that I'm staying away from, fractions. Alright? I can do fractions. It is quicker and easier for me to not do fractions. Alright? Now, eventually you'll be able to rule out things. We're like, oh, I know I can automatically get rid of all the negative numbers. Right, not right now. But eventually you guys are going to have another rule that says, allow you to say, okay, I don't need to even look at the negative numbers, or I don't need to look at the positive numbers, or I don't need to look at any number that's lower than 3. Alright? So, right now we don't have to do that though. So, Sean chose -2. Alright? So, we're gonna do, I want you guys to do -2. I want you guys to do synthetic division with -2. Tell me if you get a 0 or not a 0. Sean, you can do 2. Let's see what you get.
No, good.
Sean, you too.
Yes.
You're a 0? Perfect. Now let's get 0. Because the scales come up here and you're in it. You guys check her work. Maybe she messed up and got crazy or something. Notice she can comfortably write on the smartboard where I have to sit down and be comfortable. Alright. So, everyone agree with that? Yeah? No? Maybe so? Alright, I agree with it. So, now here's what I'm going to do. Okay. I'm going to write this in factored form now. So, if x equals -2 is a 0, how would I write that as a factored form? As a factor. So you can get the factored form by taking x equals -2 and sort of reversing the factored form. So factored form is x plus 2 times, alright, my initial degree was what? Initial degree cubed, so it's in the third power. So this is going to start with squared minus 13x plus 4. Well, that's awesome. You know why that's awesome?
Wow.
Because while you guys are all checking all 16 of those numbers, I'm factoring that and getting done much quicker than you. I want to find out what all those zeros are. So, there we go. I'm still at x plus 2 here. Factoring this, that's going to give me 3x squared. I'm going to have minus 12x minus x plus 4. Alright, so that's going to allow me to factor a 3x out of these two terms. So I have 3x times it would be x minus 4. Factor a positive 1 over here. X plus 2 times 3x plus 1 times x minus 4. I factored it. Now, I've also killed Lucas. Right? And, oh, I do, you're right. That should be a, so this should actually be a, minus 1 right there. Now it should be a minus 4. Thank you, good catch. So, that should be 3x minus 1. Alright, so there's my factored form. Now, let me quickly go find my zeros. I know one of my zeros is x equals -2. I know I'm going to set 3x minus 1 equals 0. I'm going to add 1 to both sides. That's going to be 3x equals 1. Divide both sides by 3. I get x equals 1/3. I also have x minus 4 equals 0. And I add 4 to both sides. Get x equals 4. Oh, cool. Let me go check my answers, because this is rational, and that's rational. They better all be up there. Positive 1/3. Yay.
Yeah.
Positive 4. Yay.
Yeah.
-2. Yay. And you guys are still checking all the positive non-fraction ones. You guys haven't even got down to 1/3 yet. You're checking those. No, you wouldn't have. You would have still been figuring out. You would have gone +1, -1. Positive,
Yeah.
big well.
Yeah. Oh.
I can't do it.
Right? So, now we're seeing these. We now have a way to figure out, no matter, you don't have to know what the graph looks like. We now have a way to figure out what could be zeros and figure out which of those are zeros. Alright? Questions? Alright, let's see something. We're going to stop there.
Okay, so